In question number 22, they ask us to graph this. Hopefully you remember from the last chapter that this is actually a circle. And in order to graph it, we need a center, which is -2, +1. And the radius is the square root of that number, so the radius is 2. So to graph it, I'm going to go to -2, 1, which is about right there. And then we have to go up 2, down 2, right 2, and left 2 from the center. So there's your circle. In question number 23, they give us the segment MP. So I tried to sketch it, except that it's a little bit off the grid. So I'm looking at this segment. I drew a right triangle and found that this distance was 10, this distance is 15, and then they tell us they want us to have a ratio of MA, so we're looking for the coordinates of A, to AP is a 3:2 ratio. Well, 3:2 means that there are 5 parts. So the first thing I'm going to do is divide each of these by 5. When I divide this part by 5, I get 2. When I divide this part by 5, I get 3. And so what I'm going to do is I'm just going to kind of follow this scale somehow. So I'm going to go 2 to the right, 3 up, 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 and 2 to the right, 3 up, and hopefully it lands in the right spot. So we're looking for A, so that M to A is 3 parts. So here's 1, 2, 3. My A should go right there, and it looks like, it's hard to tell from my graph, that A is at about 1, 4. Please check it on your graph paper to see if you can get that more accurate, but that's the way that you do the problem. In number 24, they ask us to graph this parabola, so I notice a few things. First of all, it's a parabola. Hopefully you know that that's a U shape, and because this 12 is positive, it should look something like this going up. I also need the vertex, and remember the vertex is the opposite of these parentheses, which is 2, -1. So the vertex is 2, -1, that's about right here. If they asked for the focal point, remember the formula has a 4p right here, so p would be 3. They didn't ask for that, they just asked us to sketch it, so it's going up like this. And I'm going to go ahead and put, that's our vertex, the focal point is up 1, 2, 3, so the focus is about at 2, 2. So it's hard for me to graph this on here. In question number 25, they ask us for the length of ST. Uh-oh, I better make this S, little typo, and a T. So they want to know this length. It's kind of like the crust on pizza. So in order to do that, I use a proportion. I always use the angle, which is part of a full circle, so out of 360, so 60 out of 360. I don't know how long this arc is, so I'm going to call that X. But then this is part of the entire circumference, just like 60 is part of a full circle. So I need the circumference formula here, which is 2 pi r. Now they told us that the radius was 27 in the problem, right here. So I'm going to plug in 27 right there. And I'm going to reduce this because right now it's pretty ugly. I can cancel the zeros and reduce this to 1/6. And then I can plug in my 27 right here. And 27 times 2 is 54 pi. And then to solve, we just have to finish cross multiplying. So when you finish simplifying it, you get 54 pi over 6, which is just 9 pi. And that's a part of the circumference. The next question is very similar. They ask us to find the area of the sector, and again we probably need a J here and a K here. And it's very similar to this formula. Again, I'm going to take the central angle, which is 90, out of 360, because that's a portion of the circle. They want the area this time though, and I don't know the area, so I call it X, but it's part of the area of a circle, and that formula is pi r squared. So I'm simply going to simplify this real quickly. Again, you can cancel your zeros by dividing by 10. You get 1/4. I don't know x yet, but the radius this time they said is 12. So I'm going to plug that in there. 12 squared is 144 with a pi. So now we just have to cross multiply to solve. And the final answer is 36 pi. And that, if you wanted to know the exact answer, it's with a pi, but if you wanted an estimate, you could use 3.14 to approximate the area. And this area of a sector is kind of like finding the area of a slice of pizza. Okay?